Hi students, okay, today we are learning the topic is problems on Fourier series expansion. In the previous lecture we discussing the basic formulas, the Fourier series expansion of the given function in the given intervals. So using that formulas we have to finding the here Fourier series expansion of the given different intervals. Okay, now see the first problem here. Obtain Fourier series for f of x is equal to e power minus x in 0 less than x less than 2 pi. So given interval 0 comma 2 pi interval. Okay, now the given function is e power minus x. See the solution. So given function f of x is equal to e power minus x in the interval 0 comma 2 pi. The formula is given by, so this is the Fourier series expansion of the given function in the interval 0 comma 2 pi, where a naught is equal to, okay, next to an is equal to, next to bn is equal to. So this is the Fourier series expansion. Now finding a naught, an, bn, substituting the given function e power minus x. So that is equal to a naught is equal to 1 by 5 into integration 0 to pi f of x dx. That is equal to 1 by 5 into integration 0 to 2 pi. So e power minus x into dx. So integration of e power minus x, e power minus x by minus 1. Substituting limit 0 to 2 pi. So upper limit 2 by 5. So minus common, minus 1 by 5, e power minus 2 pi minus e power 0 into 1. Okay, na? This is the a naught is equal to 1 by 5 into 1 minus e power minus 2 pi. Okay, similarly we have to finding an value. So an is equal to 1 by 5 into integration 0 to 2 pi f of x cos nx dx is equal to 1 by 5 into integration 0 to 2 pi e power minus x into cos nx dx. So now finding the integration, this one. So by using the formula e power ax into cos bx form and integration. So 1 by 5 into e power minus x by a square plus b square, and a is equal to minus 1 square plus b square ante n square into a cos bx, a ante minus 1 cos nx plus b sin bx, and b is equal to n into sin nx, 0 to 2 pi limits. Substituting upper limit 2 pi e power minus 2 pi by 1 plus n square into cos 2n pi and 1 and minus 1 sin n 2n pi and 0. Next lower limit 0. ఏమొస్తుంది e power 0 అంటే 1 by 1 plus n square. So cos 0 1 minus 1 plus sin 0 అంటే 0. So here common 1 by 1 plus n square common, 1 by 5 into 1 plus n square into 1 minus e power minus 2 pi. This is the an value. Next to bn value, similarly 1 by 5 into 0 to 2 pi f of x sin nx into dx is equal to 1 by 5 into 0 to 2 pi e power minus x into sin nx into dx. So by using the same formula e power ax into sin bx, e power minus x by minus 1 square plus n square into minus sin nx minus n cos nx 0 to 2 pi 1 by 5 into e power minus 2 pi upper limit substituting e power minus 2 pi by 1 plus n square into here sin 2n pi and 0 minus n into cos 2n pi and 1 day 1 n minus lower limit e power 0 1 1 by 1 plus n square sin 0 0 cos 0 1 and minus n. So here common n common by n plus n square common, n by 5 into 1 plus n square into 1 minus e power minus 2 pi. So this is the bn value and okay na. So substituting a naught an bn in equation 1, the required Fourier series of f of x is e power minus x into, so this is a naught by 2 kada, it's a naught value plus summation n is equal to 1 to infinite an into, this is an value into cos nx plus bn into sin nx, this is the b value into sin nx. This is the required series of the given function. Okay, see the next problem. Yeah, obtain Fourier series for f of x is equal to mod x interval minus 5 comma 5. Hence, show that 1 plus 1 by 3 square plus 1 by 5 square plus up to so on pi square by 8. This is a important question. So given function f of x is equal to mod x in the interval minus 5 comma 5. So mod x function, which is deleted mod from the given function. Mod x is defined x less than 0 and x greater than 0. 0 is between minus 5 to 5. Okay, that is equal to, which is can be write mod x minus x when minus 5 less than x less than 0. Avuna, x less than 0 kada, the before value minus 5. So in the case minus 5 to 0, that is minus x. Next to plus x when x greater than 0 kada, 0 to pi. 0 less than or equal to x less than pi. So this is the modulus function. Okay. So now finding Fourier series in the function mod x in the interval minus 5 comma 5. So this is the formula is given. Okay. So where a naught is equal to an is equal to bn. This is a naught, an, bn. Okay. Next one, finding a naught value. A naught is equal to 1 by 5 into integration minus 5 to 5 f of x dx. But given function f of x defined in two cases here. So here minus 5 to 0 and 0 to 5. So integration is also can be separating into integrals. That is equal 1 by 5 into minus 5 to 0 f of x dx plus 1 by 5 into integration 0 to pi f of x dx. That is equal to 1 by 5 into integration minus 5 to 0 into f of x is equal to, in this case, minus x into dx plus 1 by 5 into integration 0 to 2 pi f of x is equal to x. That is equal to 1 by 5 into integration of minus x square by 2 limits minus 5 to 0, 1 by 5 into x square by 2, 0 to 2 pi. Substituting, after simplification we getting the value pi. This is a naught value. And okay. Next an value. So an is equal to 1 by 5 into minus 5 to 5 f of x cos nx dx. That is equal to, the integration is also separating in two cases. 1 by 5 into integration minus 5 to 0 f of x is equal to minus x into cos nx dx plus 1 by 5 into integration 0 to pi f of x is equal to x into cos nx. So now integration is bypass method, u into v method. So minus x into integration of cos nx into sin nx by n minus derivative of x into 1. So one constant, 2 time integration of cos. That is equal to minus to minus plus here, cos nx by n square. Limits minus 5 to 0. Plus 1 by 5 into x into integration of cos under sin nx by n minus derivative of x into 1. Cos की 2 times integration minus of minus plus cos nx by n square, limit 0 to pi. So 1 by 5 into substituting upper limit 0, this is a 0. Next to cos 0 1 by n square, lower limit minus 5 substituting sin n pi 0. So minus of minus plus cos minus of n pi and cos n pi by n square. Next 1 by 5 into here upper limit pi, sin n pi 0 plus cos n pi by n square, lower limit 0, sin 0 0 minus 2 plus minus cos 0 1 by n square. The simplification is 2 by 5 n square into minus 1 power n minus 1. Since cos n pi is equal to minus 1 power n, sin n pi is equal to 0. This is an value. Similarly, bn is equal to 1 by 5 into minus 5 to 5 f of x sin nx into dx. That is equal to 1 by 5 into minus 5 to 0 minus x into sin nx into dx plus 1 by 5 into integration 0 to pi x sin nx into dx. So by pass method again, 1 by 5 into minus x into integration of sin minus cos nx by n minus derivative of minus x into 1 minus into minus plus sin nx को 2 time integration sin nx by n square minus 5 to 5 limits. Second one, 1 by 5 into x into integration of sin minus cos nx by n minus derivative of x into 1 sin को 2 times integration minus, so minus into minus plus sin nx by n square 0 to pi. 1 by 5 into substituting limits 0, second one sin 0 0 Next one minus to minus plus, plus into minus minus, minus to minus plus 5. 5 into cos n pi by n minus sin n pi 0. Next 1 by 5 into x is equal to pi minus pi cos n pi n sin n pi 0, x is equal to 0 0 sin 0 0. Simplification is 0. Bn is equal to 0. So now substituting a naught, a n, b n in equation 1, that is equal to we getting the required Fourier series of f of x is mod x is equal to f of x is equal to mod x here 5 by 2 plus summation n is equal to 1 to infinite. This is the a n value into cos n x plus bn. Bn is equal to 0 kada sin n x. So that is equal to mod x is equal to 5 by 2 summation n is equal to 1 to infinite 2 by 5 into n square into minus 1 power n minus 1 into cos n x. This is the required series of the mod x. And one more thing, mod x is always even function kada. So x plus to minus x plus is again it's the same function and the minus 5 to 5 interval kada. So similarly using that formula for even function a naught a n kada, bn automatically 0. So that using that formula also shortcut method we can use, we getting the same answer. Already bn is 0 వచ్చింది కదా. So mod x is always even function in the interval minus 5 comma 5. Using that formula also we getting the same answer. Okay na? So now showing that given condition, since clearly given function f of x is equal mod x is continuous at x is equal 0 in the interval, so that one known condition f of x is at the point 0 is continuous. The series total series right side of the equation 2 is convergence to f of 0. So f of 0 is equal to here 0. Substituting x is equal to 0 in equation 2 we get, so 0 mod 0 is equal to 0. Okay na? 5 by 2 plus summation n is equal to 1 to infinite 2 by 5 n square into minus 1 power n into minus 1 cos 0 1. Now expand the series 5 by 2 minus n is equal to 1 4 by 5 plus n is equal to 0 n is equal to 3 4 by 9 5 plus n is equal to 4 0 minus n is equal to 5 4 by 25 5 plus up to so on. So 5 by 2 minus 4 by 5 common 1 plus 1 by 9 plus 1 by 2 25 plus up to so on. Therefore 4 by 5 common right outside 5 by 2. So therefore 1 plus 1 by 3 square plus 1 by 5 square plus up to so on 5 square by 8. This is the required result proved. So this is the important question. Okay, see the next question. Express the function f of x is equal to 2x plus 1 in the interval minus 2 comma 2. So this is a minus 2 comma 2 means minus L comma L interval and so that is equal to given function f of x is equal to 2x plus 1 in the interval minus 2 comma 2 where L is equal to 2. So the series of in the interval minus L comma L, so this is the Fourier series expansion of the given function in the interval minus L comma L. This is the a naught value, this is a n value, this is the b n value. So now finding the a naught, a n, b n. A naught is equal to 1 by L into integration minus L to L f of x dx is equal to 1 by 2. L is equal to interval minus 2 comma 2. L is equal to 1 by 2 into integration minus 2 to 2 given function 2x plus 1 into dx. Now finding the integration 1 by 2 into here x square plus x limits minus 2 2. So substituting here 1 by 2 into 4 plus 2 minus 4 plus 2 that is equal to 2. So a naught is equal to 2n. Similarly we have to finding the a n value. So a n is equal to 1 by L into integration minus L to L f of x into cos n pi x by L into dx. So 1 by 2 into integration minus 2 to 2 2x plus 1 cos n pi x by 2 L is equal to L. So now bypass method, u into v method. So 1 by 2 into u into 2x plus 1 into integration of cos sin n pi x by 2 x coefficient n pi by 2 minus 2x plus 1 derivative 2. This is 2 is a constant, cos की 2 time integration minus cos n pi x by 2 by n pi by 2 whole square. This is a coefficient minus 2 2. So substituting n is equal to 1 2 2 cancel here, sin n pi 0. So minus to minus plus ఇక్కడ ఏమొస్తుంది 4 into 2 8 8 by n square 5 square cos n pi x is equal to 2 cancel. Next lower limit x is equal to minus 2 అంటే sin n pi 0 minus to minus plus plus into minus minus 8 by n square 5 square cos n pi. So observing both are equal కదా 0. This is a cancel కదా. So an is equal to 0. Next bn is equal to 1 by l into integration minus l to l f of x into sin n pi x by l into dx, that is equal to 1 by 2 into integration minus 2 to 2x plus 1 into sin n pi x by 2 into dx. Bypass method 1 by 2 into 2x plus 1 into sin integration minus cos n pi x by 2 by n pi by 2 minus 2 into integration x to x plus 1 की derivative 2 sin की 2 time integration minus sin n pi x by 2 by n pi by 2 whole square. So that is equal to substituting upper limit first 1 by 2 into here 2 into 2 4 plus 1 5 into 2 10 10 by n pi ఇక్కడ minus cos n pi sin n pi 0 lower limit minus 2 substituting. So minus 4 plus 1 and minus 3 into 2 minus 6 by n pi into cos 0 అంటే cos of minus 2 అంటే cos n pi. Next minus to minus plus sin 2n pi 2 2 cancel అంటే sin n pi 0. Okay na. So that is equal simplification is, so this is a both are same కదా minus 8 minus 6 minus 16 కదా అంటే minus 8 by n pi into minus 1 power n. This is a bn value. Substituting a naught a n bn in the equation 1, the required Fourier series is 2x plus 1 is equal to a naught by 2. A naught is equal to 2 by 2 plus 1 summation n is equal to 1 to infinite a n is equal to 0 into cos n pi x by 2 plus bn is equal to minus 8 by n pi into minus 1 power n into sin n pi x by 2. That is equal to 1 minus 8 by 5. 8 by 5 is a common. 1 minus 8 by 5 summation n is equal to 1 to infinite minus 1 power n by n into sin n pi x by 2. This is the required Fourier series of the given function. Okay. Okay, see the next question. Find Fourier series of f of x 5x in the interval 0 to 1, 5 into 2 minus x in the interval 1 comma 2 in the final interval 0 comma 2 1. Okay na. So observing here 0 comma 2 is 0 comma 2l 0 comma 2l and l is equal to 1. Okay na. So that is equal to given function and 0 comma 2 is equal to 0 comma 2l where l is equal to 1. Therefore given Fourier series of the given function in the interval 0 comma 2l interval is given by, this is the f of x, this Fourier series, this is the a naught, this is the an, this is the bn value. Okay na. Now first finding a naught value. A naught is equal to 1 by l into integration 0 to 2l f of x dx. So that is 1 by 1, l is equal to 1 కదా na. Integration 0 to 2 0 comma 2l అంటే 2 f of x dx. But given function 0 comma 2 is defined in two cases కదా. The interval discontinuity point 0 to 1 and 1 to 2. So integration is also separate. So 0 to 1 f of x is equal to 5x into dx plus integration 1 to 2 f of x is equal to 5 into 2 minus x into dx. So finding the integration 5 into x square by 2 0 to 1 plus 5 into 2x minus x square by 2 from 1 to 2. That is 5 by 2 minus 0 here 5 into 4 minus 2 plus 1 by 2. Simplification is pi. So a naught is equal to pi. So next one, an value. An is equal to 1 by L into integration 0 to L f of x into cos n pi x by L into dx is equal to 1 by 1. L is equal to 1. So integration 0 to 2 f of x cos n pi x dx. So this is also integration separating in two cases. It is equal to 0 to 1 pi x into cos n pi x dx plus integration 1 to 2 5 into 2 minus x into cos n pi x dx. So bypass method, this is a u, this is a v. Pi x into integration of cos sin n pi x by n pi minus derivative of phi x and x pi integration of cos 2 times cos n pi x by n square pi square from the limit 0 to 1 plus this is also u into v. 5 into 2 minus x integration of cos sin n pi x by n pi minus derivative of 5 into 2 minus x అంటే minus 5 cos కి 2 time integration minus cos n pi x by n square pi square from the limits 1 to 2. Substituting here x is equal to 1 sin n pi 0, ఇక్కడ x is equal to 1 cos n pi minus to minus plus cos n pi అంటే minus 1 power n by n square pi minus lower limit x is equal to 0 0 the cos 0 1 minus to minus plus into minus 1 by n square pi. Next second value n is equal to sin 2n pi 0 minus to minus plus into minus x is equal to cos 2n pi అంటే 1 plus 1 by n square pi. Okay, minus 1 power n by n square pi. ఇక్కడ pi cancel కదా. So simplification is all are same terms here. So this is the same term 2 by n square pi. This is the same terms 2 into minus 1 power n by n square pi. Here common 2 by n square pi common, that is minus 1 power n minus 1. This is the an value. Next similarly we have to finding bn value 1 by L into integration 0 to L f of x into sin n pi x by L. L is equal to 1 by 1 integration 0 to 2 f of x into sin n pi x dx. So this is also separating the integration 0 to 1 pi x into sin n pi x dx plus integration 1 to 2 pi into 2 minus x sin n pi x into dx. So that is pi x into minus cos n pi x by n pi minus pi x అంటే pi integration of sin 2 times minus sin n pi x by n square pi square limit 0 to 1 plus here 5 into 2 minus x అంటే u into 5 into 2 minus x integration of sin minus cos n pi x by n pi minus of derivative of 5 into 2 minus x into minus pi sin కి 2 time integration minus sin n pi x by n square pi square. So substituting lower limit x is equal 1 ఇక్కడ pi cancel minus cos n pi అంటే minus 1 power n sin n pi అంటే 0 x is equal 0 అంటే this is the 0 sin 0 here lower limit upper limit here 2 minus 2 0. So next one sin 2n pi 0 lower limit x is equal 1 2 minus 1 pi cancel cos n pi here lower limit here minus to minus plus minus 1 power n by n pi ఇక్కడ pi cancel plus sin n pi అంటే 0. So that is equal to cancel కదా. So that is equal to 0. bn is equal to 0. So now substituting a naught an bn in the given equation, the required Fourier series, substituting all values in the equation 1, therefore the given series f of x is equal to 5 by 2 plus summation n is equal to 1 to infinite 2 by n square pi minus 1 power n minus 1 into cos n pi x plus 0 into sin n pi x. 0 kada bn value 0, therefore f of x is equal to 5 by 2 plus 2 by 5 into summation n is equal to 1 to infinite 1 by n square into minus 1 power n minus 1 into cos n by x. So this is the required Fourier series of the given function in the interval 0, 2. So next one, okay, find Fourier series expansion of the function f of x is equal to minus 5 in the interval minus 5 to 0 and x 0 to 5, and hence show that 1 by 1 square plus 1 by 3 square plus 1 by 5 square plus up to so on pi square by 8. This is also very important question. The same procedure in the interval is minus 5 comma 5 interval. So this is a given function in the interval minus 5 to 5 interval. So this is a given Fourier series of expansion where a naught is equal to an is equal to and bn is equal to. First finding a naught. So given function is also defined in two cases. The breaking point is 0, discontinuity, minus 5 to 0 and 0 to pi. So integration is also separate. This is a naught value 1 by 5 into integration minus 5 to 0 f of x is equal to minus 5 into dx plus 1 by 5 into integration 0 to pi f of x is equal to x, that is equal to minus pi cancel, integration of 1 x minus 5 to 0 plus 1 by 5 into integration of x square by 2 limit 0 to pi. So that is equal to minus 0 minus 5 plus 5 by 2 minus 0, that is equal to minus 5 by 2. A naught is equal to minus 5 by 2. This is the a naught value. Next to finding a n value. So a n is equal to 1 by 5 into integration minus 5 to 5 f of x into cos nx dx, that is equal to 1 by 5 into integration minus 5 to 0 minus 5 into cos nx into dx plus 1 by 5 into integration 0 to pi x into cos nx dx, that is equal to bypass method, and this is a constant minus 5 cancel, integration of cos and sin nx by n limits minus 5 to 0 plus 1 by 5 into u into v method x into integration of cos sin nx by n minus 1 derivative of x into 1 cos 2 time integration minus cos nx by n square. Substituting the limits, sin 0 0 plus sin n pi 0 1 by 5 into pi is x is equal to pi sin n pi 0, so minus to minus plus cos n pi by n square, lower limit 0 into and 0 minus to minus plus into minus cos 0 1 by n square. So that is equal to here common 1 by n square common, that is 1 by n square pi into cos n pi into minus 1 power n minus 1. This is a n value. Next to bn value, this is a bn value. So integration separately, 1 by 5 into integration minus 5 to 0 f of x is equal to minus 5 into sin nx dx plus 1 by 5 into integration 0 to pi f of x is equal to x sin nx into dx, that is equal to minus 5 into integration of sin minus cos nx by n limits minus 5 to 0 1 by 5 x into sin nx u into v method, u this is a v, 1 by 5 into x into integration of sin minus cos nx by n minus derivative of x into 1 sin derivative 2 times minus sin nx by n square. Substituting minus to minus plus cos 0 1 by n plus into minus cos n pi by n plus 1 by 5 into x is equal to 5 minus 5 into cos n pi by n sin n pi 0, lower limit 0 sin 0 0. Okay, so simplification is 1 by n into this, both are same value, pi cancel, 2 cos n pi by n, 1 by n common, 1 minus 2 into cos n pi is equal to minus 1 power n. This is the bn value. Okay na? Substituting a naught, an, bn in equation 1, that is a required Fourier series of the given function. So that is equal to required Fourier series f of x is equal to minus pi by 4 plus summation n is equal to 1 to infinite. This is the an value into cos nx plus this is the bn value into sin nx. So put x is equal 0 for we are showing the given conditions. Okay na? So put x is equal 0, that is equal to f of 0 is equal to minus pi by 4 plus 1 by 5 is a constant common, summation n is equal to 1 to infinite 1 by n square into minus 1 power n minus 1 into cos 0 1. This is a sin 0 0. This is a totally 0 only. Okay na? But we know that we have f of 0 kada. F of 0 is the finding value. But at the point 0 the given function is discontinuous because left and right values is a different. Minus 5 inkoti x kada. At the point x is equal 0 both are not equal. So left continuity and right continuity both are not equal, that is a discontinuous. So that the given Fourier series of the given function is convergence to the average of the left and right continuity, that is equal discontinuous at the point 0. Then we have, so this is a left continuity f of 0 minus 0 limit x tends to 0, f of x is equal to limit x tends to 0 and left value is f of x is equal minus 5 kada. When x greater than 0 kada. When x less than 0 f of x is equal to minus 5. So limit is minus 5. Right continuity f of 0 plus 0 f of limit x tends to 0 plus f of x is equal to limit x tends to 0 when x greater than 0. When x greater than 0 f of x x. So x is equal to 0. So therefore f of 0 is equal to average of the both values, that is equal average is minus 5 plus 0 by 2, that is minus 5 by 2. So f of 0 is equal to minus 5 by 2. So this is the right side of the Fourier series is convergence to the minus 5 by 2. So from equation 2, minus 5 by 2 is equal to minus 5 by 4 plus 1 by 5 into summation 1 by n square into minus 1 power n minus 1. Expand the series minus 5 by 2 right inside minus 5 by 4 plus 5 by 4. 1 by 5 is the common. This is expand. N is equal to 1 minus 2. N is equal to 0. N is equal to 3 minus 2 by 3 square. N is equal to 4 0. N is equal to 5 minus 2 by 5 square plus up to so on. Simplification is minus 5 by 4 is equal to minus 2 common. Minus 2 by 5 into 1 plus 1 by 3 square plus 1 by 5 square. Hence now write outside cross product 1 by 1 square plus 1 by 3 square plus 1 by 5 square is equal to up to so on equal to 5 square by 8. So this is a required result is proved. Okay. So this is some problems on Fourier series expansion of the given function in different intervals. So for more videos please do subscribe my channel, like and share it. Thank you.